start working through some of this. If you weren't here on Tuesday, this was the content that we covered. It's on pages 20 through 23 of the packet. And we kind of are shifting now to a more geometric part of algebra. And so we're going to be looking at graphing and lines and things like that. So the first thing we started with on Tuesdays is how to identify a point by coordinates. And if you were here, we talked about that there's an x-axis that's in yellow, and there's a y-axis in orange. And the x-axis is just like a number line. The negative numbers are to the left, positive numbers are to the right. And the y-axis, the vertical orange axis, is like a thermometer. Positive temperatures are up, negative temperatures are below this middle area. This middle point here, right where they cross, is called the origin. And that means beginning. And anytime we want to plot a point, we start at the origin. So to find the coordinates of A, I start at the origin and I say, how many units do I have to go left or right and then up or down to get to A? So I have to go 3 units to the left, which is -3. And then I have to go 2 units down to get to point A. And so the coordinates would be -3, 2. We always put the x coordinate first and the y coordinate second. And the x coordinate, you can see an x over here on our axis. That's the x-axis. And then the y is the vertical axis. So x determines left or right movement. Y determines up or down movement. And they always go in here as XY. That's alphabetical is one way to remember it. X becomes before Y in the alphabet. Okay, so if I want to get to point B, I start back at the origin and I say I have to go 1, 2, well, just 2 units to the right, which is positive. And I have to go down 1, 2, 3, 4 units to get to B. And so the coordinates of B are +2 to the right, down 4. Then for point C, when I start back in the middle here, I have to go to the right 4, which is +4, and I don't have to go up or down any. I move 0 up and down. And so I have 4, 0 as the coordinates of point C. So those would be the XY coordinates of those 3 points. Now the second thing it then asks you to plot these points. Point D, -3, 2. That means I start at the middle and I go 1, 2, 3 to the left because that's negative, and I go up 2. And so point D should be up here. Point E, I start at the middle, I go to the right 4 and up 1. So point E is right above point C. And then for point F, I go to the left 2 and up or down 0. And so it's right there on the axis. Okay. Any questions that you have about graphing? Just graphing points. Okay, that's the first skill you need to be able to move into what we're going to be doing with equations and lines. So questions 3 and 4 are having you graph the line y = x - 3 or y = x divided by 3 plus 1. And we talked about the fact that when we solved equations like 2x + 1 = 5, there's only one answer to that problem. And the answer would be 2. Because 2 times 2 plus 1 is 5. There's only one number that fits in that equation that is a solution, okay? Now we're saying that our equation is expressing the relationship between the x value and the y value. And so now we have that y is equal to whatever x is, take away 3. And so if you want to find solutions to this, it means you can pick any number you want for x, put it in there and see what the corresponding Y value is. And so I tried to get you started just by giving you some numbers to think about first. You don't have to pick 3, 2, and 1. But if you did, or whatever number you picked, you would say, well, the Y value is equal to 3 minus 3, because I'm going to take this 3 for X, I'm going to put it in here for X, and Y equals 3 minus 3, which I just saw in the chat someone put is in fact 0. Thank you. So that means when X is 3, Y is 0. And that also means that 3, 0, the point 3, 0 is a solution to this equation. Okay. And we're going to look at what it looks like on the graph in just a minute. Then it means I'm going to take 2 and I'm going to put it in for X, and Y is equal to whatever 2 minus 3 is. This is where you can take your calculator if you're having some issues just with the integers and working with positive and negative numbers. You can put it right in the calculator, let it do the, oops, I already had one, let it do the work for you. And you would just put in the calculator 2 minus 3 and have it help you get that answer. And so all I did was put 2 minus 3 in the calculator, and it tells me that the answer is -1. And so that means when X is 2, Y is -1. If I put in 1 minus 3, you can use your rules and figure it out. You can use your calculator, but whichever way you do it, you should come up with -2. And you might have chosen 0. Maybe you chose 5. It doesn't matter if you chose different numbers, and I'll show you why in just a minute. Y equals 0 minus 3, which is -3, or Y equals 5 minus 3, which equals 2. Okay, so if your numbers in the graph are different, or in this table are different, that's okay, as long as if you chose 3, you should get 0 for Y. If you chose any of the same X's I did, you should get the same Y. But let's say you put in 4 and I didn't, that's okay. And then what we do is we take these XY values and we're going to graph them. Okay. So 3, 0 means start at the middle, go to the right 3 and up 0. 2, -1 means I go start at the middle again. I go to the right 2 and down 1. 1, -2 means I go 1 to the right and down 2. 0, -3 means I go left and right 0 and I go down 3. And then 5, 2 means I go over 5 and up 2. Now your dots, your points may not be the same points as mine, but they should be all in a row and they should be in this area. If we compared your line to my line, it should be in exactly the same place, even if you didn't pick the same points that I did. Because when I draw that line, your line should be in the exact same position that my line is in. If you're at home and you're working without graph paper, it's a little more challenging, but hopefully your line is in this area here. And this line we talked about yesterday, this line represents all of the solutions for this equation. And every single equation we're going to work with should form a perfectly straight line. Okay. So that's why even if you pick different numbers for X, they might fall in different places on this line, but you'd get the same line when you draw the line. We put arrows on the end because it really goes forever. I could make this grid paper bigger and bigger and go instead of stopping at 5, we could go to 10 and 10, and that line would just continue up there. So the question that's below was trying to kind of get you to think about tying all this together. Is 4, 7 a solution to the equation y equals x minus 3?
No.
Okay, I heard a no. Why not? That's correct. Why? Sorry, can you say it one more time?
Backwards.
It's backwards. Okay, how do you know it's backwards? Or what do you mean by that?
X minus 3 equals 4. So X.
Okay. You may have noticed that if we subtracted, if we put 7 in for x and subtracted 3, we'd get 4 for y. So 7, 4 would actually work, but there's a couple ways to answer this question. You can say, okay, if 4 is x and 7 is y, that means if I put 7 in for y and 4 in for x, it should make a true statement. And 4 minus 3 is 1, and 7 is not equal to 1. So it's not a solution. Okay. So I want you to get this idea of this vocabulary of what makes a point a solution. One way a point is a solution is if you put the x in for x and the y in for y, that it makes a true statement, and this one does not. Another way you could answer this question is if I look at where is 4, 7 on this graph? Well, 4, 7 would be over 4 and up 7, which is off the graph, but it'd be somewhere up here, right? Is that point on the line? No, it's not. If it's not on the line, it's not a solution. Okay, so that point, I probably should have picked a point that would have actually fallen on the graph, but I didn't. So this point is not on the line. So it's not a solution. Okay, so there's a couple ways to answer these questions that are below the graphs. You can substitute it into the equation and say, does it make a true statement? If it does, it is a solution. Or you can look at your graph and say, is that point on my line? If you can answer yes, then it is a solution. If not, then the answer is no. Okay. So number 4 was similar to one that we worked through yesterday, where we have a fraction that nobody likes. And there was a hint in the homework, and hopefully you remembered it because I forgot to write the same hint, is you're going to have to take this x value and you're going to have to divide it by 3. And so since you can pick whatever x value you want to, we should pick a value that divides nicely by 3. So can people suggest some numbers that would be good numbers to pick? Or sorry, I missed that, Ryan.
Even.
Even no, if I pick 2, 2 divided by 3 leaves me a fraction. I don't want a fraction. I want to divide it evenly. Adrian, 3 would be a good one because 3 is divisible by 3. Okay, 9's going to put us off the graph. So 9 would work, but it's going to be hard to graph 9.
-3.
-3 would be a good one because it's divisible, evenly divisible by 3. What's the easy peasy, always easy number to pick? 0. Okay. And actually, I should have made you a bigger graph. Probably the next easiest number is 6 and -6, which are technically off the graph, but only by 1 unit. So we'll use those. Okay. So this means to find y, I take my x value of 3, I divide it by 3, and then I add 1. 3 divided by 3 is 1, and 1 plus 1 is 2. I do the same thing with -3. Negative 3 divided by 3, the signs are different, so the answer is negative 1 plus 1 is 0. If I put 0 in for x, anything, 0 divided by anything is still 0, plus 1 is 1. If I put 6 in for x, it means I do 6 divided by 3, which is 2, plus 1 is 3. And the last one, negative 6 divided by 3 plus 1. Negative 6 divided by 3, the signs are different. So my answer is negative 2 plus 1. Now my signs are different, but I'm adding, so I subtract the numbers and I keep the sign of the larger value. So I subtract 2 and 1 and get 1, and 2 is bigger than 1, so I keep it negative. Okay. You technically don't need 5 points to graph the line. At minimum, I would choose 3, because if you get 3 points that are not in a row, you know you've made a mistake. If you only do 2 points, you can think that you just connect those 2 points with a ruler, but if one of the points is incorrect, you won't know it. So to graph this, I do over 3 up 2. I go to the left 3 and up and down 0. 0, 1 says go left and right 0 and just go up 1. And you can see, look, my 3 points are forming a line. Okay, I can line those up on my ruler. If you want to go ahead and estimate where 6, 3 is, you would go over 6 and up 3. So it would be about here. And then negative 6, negative 1 would be over to the left 6 and down 1. And you can see that they make a nice straight line. We don't ever want to graph fractions, just because then we're estimating here and estimating the fraction there, and then we have a hard time creating a straight line. Now, if you made some math errors with your y values, like when you were dividing or when you were adding and subtracting them, you might have found that your points were kind of all over the graph. They didn't make a straight line. That tells you you've got an error somewhere, because every single one of these equations, y equals something, is going to be a straight line every single time. Okay. And so that's a way to check yourself. If your points are scattered about the grid, then you go, okay, I've made a mistake. Then hopefully you can go back and figure out your mistake. All right, so the bottom question is negative 3, 0 a solution to the equation? Was that a yes or a no?
Yeah.
That's a yes.
That's a yes. It is a solution to the equation, and you can, and this problem, you could actually figure it out 3 different ways. Okay. Negative 3, 0 was in our table, so it's clearly a solution. Negative 3, 0 is a point on our graph, so it's a solution. Or if you didn't pick negative 3, 0 in your graph, you could substitute in. Remember, negative 3 goes in for x, 0 goes in for y. And you would get, remember, negative 1 plus 1 is 0. You would get a true statement. And so that means it is a solution. as the graph is showing us all the points that are solutions. So I can get it from the graph. I can plug it into the equation, or if I happen to choose that number in the table, I can see it there as well. Thoughts, questions? This feel easy?
Well,
No?
yeah.
Yes. Okay. Wonderful. There's at least one yes. All right. We're going to look today at another way to graph lines.
Can I
Okay.
look at number one?
Yes, you sure can. We're going to look at it. It's similar to what we did yesterday, just a little bit, or Tuesday. It's a little bit different. And, but it's another way to graph lines. And we're going to be on page 24 of the packet. Carrie, you good to go? Terry, can I take this away now?
Yeah, go ahead.
Okay, thanks. I can put it up there again after class if you need. Okay, so 24, page 24 is where we're at. It says using intercepts to graph lines or to graph a line. Okay. And I think we used this word on Tuesday, but if not, or if you weren't here, an intercept. An intercept is where a line crosses an axis. So remember, our y-axis is up and down. It's marked by y. Our x-axis is horizontal. It would be marked x, except when I photocopied this page, apparently I cut it off. So x would be there if I hadn't cut it off. And so the intercepts are the points where you cross these axes. So the point up here that's at 3 is the y-intercept. And the point right here is called the x-intercept. And the reason it's called the x-intercept is because it's where it crosses the x-axis. And the y-intercept is where the point or the line crosses the y-axis. So we have y-intercept and x-intercept. And so the y-intercept of this line that's on our page is 0, 3. And the x-intercept is -1, 0. And I guess something you might observe that would be good to observe. Yeah, Ryan, interception, just like football. Exactly. This line is running into the axis. The y-intercept and the x-intercept, if you look at their coordinates, one observation you might make is both of those coordinates have a 0 in them. The y-intercept will always have x equal to 0. The first coordinate will always be 0 in our x and y. And our x-intercept will always have y equal to 0 in our xy coordinate. So it's kind of reversed. The y-intercept has the first x value as 0, and the x-intercept always has the second y value as 0. So when we look at this first example, the equation is 3x minus 5y equals 15. Can anyone tell me, how does that equation look different from the equations we were working with in the warm-up and on Tuesday? Anybody notice a difference between like that equation and number 3? Well, one thing I notice is all the equations we worked with on the warm-up and all the equations we worked with yesterday had y equals something. This equation has x and y over here together. Okay. Yesterday, it was always y. There was never anything in front of the y. And now we have a number in front of the y and x and y together on this side. Okay. And so when you have an equation like we've been working with us on Tuesday and this morning, making this table of points is usually the easiest way to do it because I can pick an x, plug it in, use the calculator, find y. Pick another x, plug it in, use the calculator, find y. With this equation, if I pick a random number, you will likely pick a number that's going to create fractions when you solve it. Because if I were to say, I'm just going to pick 1 for x. If I put 1 in for x, that means I have 3 minus 5y equals 15. I would subtract 3 from both sides and I'd get negative 5y equals 12. And then I would divide by negative 5 and I would get y equals the fraction negative 12 over 5, which is a real bummer to graph. So it's really hard to pick a number for x that you know is going to work out to something nice. Okay. So when you're faced with an equation like this, the fastest and easiest way to do it is to pick the number that I say is always the friendly number to choose. If you get to choose a number, what's usually the easiest number to pick? 0. And so we're going to pick 0 and put it in for x. Okay, so they've taken the equation 3x minus 5y equals 15, and they have taken out the x and they've put in a 0. The nice thing that does is it wipes that number out because 3 times 0 is 0. Okay, and so that just leaves us with negative 5y equals 15. And then how do we solve this one-step equation? Negative 5 times y. The opposite of multiplication is division. Negative 5 divided by negative 5, any number divided by itself is 1. And 15 divided by negative 5, signs are different. Answer's negative. 15 divided by 5 is 3. Again, you can do that in your calculator. And so that avoided this yucky fraction that I got by just picking a random x. It's going to be really hard to pick a random x and not be stuck with a fraction. But if we pick 0 for x, it wipes out that term, and then I get a nice number. So I put in x for 0, and I got out y is negative 3. So that gives me the point 0, negative 3. So I have 1 point for my line. Okay. So we can do the same thing and put 0 in for y and see what we get for x. So they took 3x minus 5y equals 15. And now they're going to put 0 in for y and figure out what x is. So if you put 0 in for y, 5 times 0 is 0. And so you're left with 3x equals 15. That's 3 times x is 15. The opposite of times is divide. And whatever we do to the left, we do to the right. 3 divided by 3 is 1. So I'm just left with 1x, and 15 divided by 3 is 5. So that tells me that 0 for y pairs with 5 for x and leaves me with a second point I can graph. And I'm not stuck graphing the point 1 comma negative 12 over 5, because who wants to graph that? Okay. So the way that you use, we're basically finding the intercepts, and then you're able to graph them. And so that is what the bottom part of this is. It's taking now the same equation, 3x minus 5y equals 15. It's taking the 0, negative 3 that we already found and the 5, 0, and it's plotting them. So to plot the point 0, negative 3, I go start at the middle, I go left and right 0, and I go down 1, 2, 3, and there's my point. Or you could say the y-intercept is negative 3, meaning this line that I'm going to draw is going to cross this y-axis at negative 3. And then the x-intercept, I start at the center and I count over 5 and I go up and down 0, and I get this point over here. Or you could say the x-intercept is 5, and so you go along the x-axis till you get to 5. Now you have 2 points, and you can draw the line. Downside of this method is if you've made an error, you're not going to know it because you can always draw a line between 2 points. All right. Questions? This method works best when you have equations like this where it's going to be really hard to pick. It doesn't say y equals when you've got your x's and your y's on the same side. All right, I'm going to move to page 25 unless someone needs me to keep this for a second. All right, so let's take a look at page 25. And let's try, so it's wanting us to use, it's calculate the coordinates of the x-intercept and the y-intercept. Okay, when you see this language, that means we're having one of the values for x or y is 0. Okay, x-intercept is going to be some number x 0 and or no, it's not. I just put that backwards. And the y, I just rewrote the same thing. What am I doing? Okay. I'm having a moment. This should be a teacher moment. Yes. This should be 0 and some y value. And this should be x and then 0. Having a moment there, a brain moment. Okay. So if it wants us to calculate and find the X and Y intercept, basically it means I'm going to substitute in 0 for X, figure out what Y is, and then I'm going to substitute in 0 for Y and find out what X is so that I get 2 points, the X intercept and the Y intercept. Okay, so I don't have much room to work here since I write too big. So I'm going to start with number 2. So if I have X plus 5Y equals -10, you may need to do this on another sheet of paper. Let's start by letting X equal 0. And then we're going to find Y. So if I put in 0 for X, that means all I did was take out the X and put in the 0. 0 plus 5Y is just 5Y. This is 5 times Y. 5 times some number is -10, and the opposite of times is divide. 5 divided by 5 is 1, leaving me just 1Y or Y. And -10 divided by 5, the signs are different, so my answer is negative. And 10 divided by 5 is 2. And so that means I have the point X was 0 and Y is -2. That's one of my intercepts. That is the Y intercept. If I was going to graph that, I would go over 0 and down 2, and I'd be sitting on the Y axis. And then if I start with the same equation again, and this time I'm going to let Y equal 0, and we're going to find X. So I'm going to take out Y, I'm going to put in 0. Instead of 5 times Y, I have 5 times 0. 0 times anything is 0. That one's really simple because this makes 0, and so it just says X equals -10. So the point is X is -10 when we put Y as 0. And that makes my X intercept, because I would go to the left 10 and up or down 0. If you've been with us for a while, if you've been with us most of the spring, you hopefully are starting to see all these skills we've been practicing are kind of coming together. We are substituting in numbers for variables. We're doing a little bit of solving equations to find an answer. And so if you're fresh new with us or haven't been with us very long, it may take you a while to get moving on some of this because we've been doing math and doing this topic of algebra for a while now. So I'd encourage you not to get frustrated. Keep at it. Are there questions about how I got the answers for number 2? All right, well, why don't you try number 4? Find the intercepts for this equation. Okay, that means substitute X equals 0, find Y. That's your first task. And your second task would be substitute Y equals 0 and then find X. Okay, so try number 4. Probably going to need another sheet of paper to do some calculating and your work on. But I'll give you like a handful of minutes to work on that and see what you can do. And then we'll talk about it. anyone needs a sign-in sheet, I just put it in the chat one more time. Okay, let's take a look at this one. If you're not quite done, that's okay. We'll see if you're stuck, we can get you going again. Okay, so we have the equation negative 2x plus 4y equals 8. And we're going to do this problem twice to get 2 points. First, we're going to substitute x for 0, and then we're going to solve for y. So the first thing I'm going to do is let x equal 0. So I'm going to say negative 2 times 0 plus 4y equals 8. If you put in 0 for y first, that's fine. You're going to just get the coordinates in the opposite order. Negative 2 times 0 is 0 because anything times 0 is 0. So we're left with 4y equals 8, which is a one-step equation like we've been solving prior to this. That means 4 times y is 8. The opposite of multiplication is division. 4 divided by 4 is 1, and 8 divided by 4 is 2. So what that means is when x is 0, y has to be 2. And there's 1 point we could graph. Okay, so that's the first step. I can't draw a line when I only know 1 point. I need at least another point to figure out where the line goes. And so this time we're going to say, let's let y equal 0 and figure out what x is when y is 0. So I have the same equation, but this time I'm going to put 0 in for y. I'm going to rewrite that because that x looks hard to read. Okay, negative 2 times x plus 4 times 0 is 8. 4 times 0 is 0, so I'm left with negative 2x equals 8. That means negative 2 times x is 8. The opposite of multiplication is division. Negative 2 divided by negative 2 is 1, leaving me just 1x. And 8 divided by negative 2, the signs are different, so the answer is negative. And 8 divided by 2 is 4. That means I have the point x is negative 4 when y is 0. And so I have 2 points, and I could graph this line now. If I just sketch it. This is what I meant for the warm-up. If you didn't have a piece of copied paper, you can sketch a graph. This is my x-axis, this is my y-axis. So this first point says go over 0 and up 2. And this point says go to the left 4, 1, 2, 3, 4, and up or down 0. And so then I could take and graph this line from those 2 points. Okay, so this equation, negative 2x plus 4y equals 8. The picture of all the solutions of this equation is this line. Now it has more points than just the 2 that I did, but they're hard to tell exactly what the points would be since I just sketched it. I didn't put it on real graph paper. But that's what the line would look like. Okay, so the direction we're headed is we're wanting to be able to take an equation, graph the line. We're wanting to be able eventually to take the line and write the equation. So we're going to do these problems, what I guess you could say forwards and then backwards. So we now know 2 ways to graph a line. We can graph a line when it says y equals, like number 1, we could do like what we did this morning earlier and Tuesday. We could just pick values for x, you get the y. Or when we have a problem like this, it's easier to use our zeros to get 2 points to draw the line. Okay. Disadvantage of this method is if you've made an error, you're not going to know because you're going to get 2 points and you're going to connect them. When we solved it by like this equation where we just picked random x's, if you picked 5 different x's and got 5 different y's and they didn't line up in a straight line, you knew you had a problem. Okay. Thoughts or questions? Because this is kind of just expanding what we've already done. I'm going to keep stretching your brain in new directions and maybe tying it in a knot or 2. But anyone got a question they'd like to ask or something they'd like to see? Like, how'd you say that again? Or how'd you work that out again? All right. Well, if you come up with one, jot it in the chat or turn on your mic and let me know. Number 5 is a comment, would be a realistic question for the GED. And you have enough skills to figure this out now. Okay. Number 5 says, which of the following is the equation of the line shown on the graph? So they're saying one of these lines, one of these equations, this is the picture for the line. Do we have thoughts about how we would figure that out?
All right, cool.
I heard something about 2, Ryan. Maybe if you type it in the chat, the mic doesn't always pick up what you're saying from way back in the back of the classroom.
4 and 2. 4 and 2.
4 and 2. Okay. What about 4 and 2? Do you mean in the equations or do you mean 4 and 2 on the graph?
Intercept.
I didn't catch
Intercept.
the intercept. Very nice. Okay. The intercepts can help us. That's one way to do this problem. The coordinates of this point are 2, 0. This point right here, because I go over 2 and up 0. And the coordinates of this point are 0, 4. So that means that the point 2, 0 would have to fit in one of these equations, and the point 0, 4 would have to fit in one of these equations. Anybody got an idea which equation it is and why? I don't actually know the answer off the top of my head, so we'll have to take your answer and then we'll have to check it and see if it's right.
I'm gonna guess these.
B and D? Okay, I've got B. D as in dog or B as in boy from Flagstaff?
B.
You think B. All right.
It's on the positive side.
Okay, so let's see, how could we check if B works? Well, if B is the right equation, it means that if I plug 0 in for X, Y better be 4. And if I plug 2 in for X, Y better be 0. So let's try it. So I'm gonna pull over here. Let's check B. Negative 2X plus Y equals 4. So I'm gonna check if I put in, I'm gonna try 0, 4. That's my X and my Y. If I put in 0 for X and 4 for Y, is that a true statement? Negative 2 times 0 is 0, and 0 plus 4 is 4, and 4 equals 4. That is true. Okay, we got to check both points though. So let's try negative 2x plus y equals 4. This time we're going to put in the other point, 2, 0. Remember the x is 2 and the y is 0. So we're going to have negative 2 times 2 plus 0 equals 4. Is that true?
Yeah.
Negative 2 times 2 is
Negative 4.
negative 4. Is negative 4 equal to 4?
Yeah.
No, negative 4 is not equal to positive 4. Those are not equal. Okay, so B actually doesn't work. So we guessed, we checked, it didn't work. No big deal. What else should we check? Which if we got a suggestion for the other, for what answer it should be?
The intercepts are on the positive side.
Yeah, but that I've got an observation, which is true. The intercepts are both positive, but that doesn't always help you answer, pick out. That doesn't necessarily mean you're going to only have positives over here.
D.
Okay, I heard D and I've got a D in the chat. So let's try D. Okay, I'm going to just slide my scratch paper around here. So if we try D, 2x minus y equals 4. Okay, we got to check 0, 4 for my x and my y. So I'm going to put in 0 for x minus 4 equals 4. 2 times 0 is 0. So I end up with negative 4 equals 4. True or false?
True.
That's false. Negative 4 is not equal to 4. Because that's the difference between you owing $4 and you having $4. That's different, right? Especially if that number is bigger. Okay, so D doesn't work. I don't even have to check the other one because D doesn't work. Okay, do we have another suggestion?
Let's go with A.
Let's go with A. All right. So A, 2x plus y equals 4. All right, so let's try 0, 4 for my x and my y. 2 times 0 plus 4 equals 4. 2 times 0 is 0. 4 equals 4. True or false? It's not a trick question. It is true.
True.
If you have $4, that's the same as having $4. Okay, so now we got to check the other one. And that is 2, 0. That's my x and my y. So I'm going to put in 2 for x. 2 times 2 is 4. 4 plus 0 is 4. True. 4 is equal to 4. That means that this line is line A. Dang it, we should have just started from the top, huh? So very, very, 5 represents a question that you could very likely get on the GED. And you don't have to know a lot about lines and equations to get it right. The key with lines and equations is if it's on the line, it will fit into the equation and make a true statement. Any point that's on the line should go into the equation and make a true statement. If the point is not on the line, like a point over here, will not fit into the equation. It'll make it false. Okay. Thoughts or questions?
A is equal to -4.
Oh my goodness. Thank you. Dang it. I wish you would have told me that before I celebrated, because what I actually did was C, wasn't it? Okay, so let's, thank you for pointing out my mistake. Did you notice it earlier?
No.
Okay, good. If you noticed it earlier, point it out right away, okay? All right, so all my celebrating, all my celebrating was for not. A is not the right answer. What I actually did was C. So thank you for pointing out that mistake. Sometimes it's hard to do math in front of a crowd. 'Cause I make silly mistakes just like you guys do. All right. So now that I've muddied the waters a bit, anyone have a question? All right, let's take a look at the bottom of the page, because that's kind of where we're headed. Although on the GED, they could ask you, they could give you an equation, and then your 4 answer choices could be 4 different graphs with 4 different lines on them. So that would be a way you could have a multiple choice question that's like number 6. Is which graph goes with which equation? Here's the equation, then they give you 4 different graphs with 4 different lines, and you have to pick out the right line or the right graph. And the way you would do that, this problem again is best solved using intercepts, so you don't end up with fractions. So to start this one, now we're going to basically put the skills together from the top of the page where we find the intercepts, and now we're going to just graph them. So if we have 2x plus 3y equals 6, and I want to know the intercepts, that means I need to substitute in 0 for the x and find the y. And then I need to substitute 0 in for y, and I need to find the x. So if we say we're going to make x equal to 0, and so I'm going to put in 2 times 0 plus 3y equals 6. Anything times 0 is 0. So I have 3y equals 6. 3 times
Have
y.
a moment.
What's that?
Oh, we froze for a moment there.
Oh, it says my internet connection is unstable. Can you hear me now?
Good.
Okay, thank you. Opposite of multiplication is division. 3 divided by 3 is 1, leaving me 1y is 2. And so now I have, when x is 0, y is 2. And so my point that I can graph is 0, 2. And I need a second point, because if I just point 0, 2 on my graph, that means I go over 0 and up to, I have 1 point right here, but I still have no idea which way to orient the ruler to draw the line. And so I have to find a second point, which I can do by using the same equation. And this time I'm going to let y equal 0. The beauty of picking those zeros is it wipes out anything that you're multiplying by it. And then this time I'm going to divide by 2, because this being 2 times x, opposite of times is divide, and 6 divided by 2 is 3. So my second point says when x is 3, y has to be 0. And so to graph that point, it says I start at the origin and I go to the right 3 and up 0. And my line looks like this. Okay, so on the GED, they claim that they put problems on the math GED, like where you have to plot a point by clicking on the graph and things like that, or a drop down menu. But everybody I've talked to that's taken the GED recently, no one has had anything but multiple choice. And so the way that they would test this would be either to give you a graph and then give you 4 equations, or give you an equation and give you 4 graphs, and you have to match them. And so knowing how to pick out these intercepts and substitute them in is a good skill. Okay. All right, we have about 8 minutes left, it looks like. So I'd like for you to try like number 8 and see if you can get the graph, the intercepts, and then get the graph. And I guess if we had written this on here, our x-intercept is 3, 0, and our y-intercept is 0, 2. All right, so see what you can do with number 8. Again, if you're at home and you don't have graph paper, go ahead and calculate, find these 2 points, and you can sketch a graph, just draw a graph and plot them. It's still good to have practice plotting, especially with these points that have 0 in them, to make sure you're not mixing up the directions of which point is on which intercept.
I need to. I'm in trouble with outside moment here, so let's take it. That you graph and load down. So you got the right answers for the errors, but you graphed it correctly. Oh, Mary, you're muted.
Okay, so Daniel astutely pointed out, I'm having some math moments, some senior moments apparently today. For number, so let's just take a look at number 6. We got the right X and Y intercept, but I recorded them backwards. So I don't know what it is about intercepts and me today. They're not getting along, but it's the Y intercept would actually be 0, 2 on number 6 because we go over 0 and up 2. And then the X intercept would be 3, 0 because we go over 3 and up 0 and end up on the X axis. So they were calculated correctly. I just recorded them backwards. Okay, so I just want to highlight that. Thank you, Daniel. And then for number 3, or number 8, excuse me, I showed my work here, so you can take a look. We're about at 11:30, but I substituted in X equals 0 first. And when I do 3 times 0, I get 0. So Y is 3, I'm done. 0, 3 is the Y intercept. And so it would go here if you want your answer to be in the right spot. And you would graph that by going over 0, up 3. And then when I do the problem again, and I let Y be 0 this time, I have 3X plus 0 is 3. Or 3X is 3, divide by 3, and then X is 1. So I have 1 for X, 0 for Y, 1, 0. That means I go over 1, up 0. I'm on the X axis, so it's the X intercept. And that's what the line looks like. Okay? So I apologize for my many math moments. Again, it can be tough to do math in front of a crowd. If you ever have fear of public speaking, just imagine doing math public speaking in front of a crowd. So anyway, I do appreciate Daniel and others who point out my mistakes. I'm never going to be upset at you if you point out my mistake. I would rather you point out my mistake so I can fix it so that I don't confuse people. So please do point out when I make errors. That's how you would find number 8. Are there questions on that? I'll stay on the Zoom for a few more minutes if someone wants to see something